What's up everyone, I'm back with another tutorial. uh, so today I'm just gonna, in this particular video, I'm just gonna talk about like how we can actually build the Kubernetes cluster. What is a Kubernetes cluster? Kubernetes cluster is so this is the Kubernetes cluster where you have one control plane and there are a bunch of different nodes. To demonstrate or illustrate, you can consider going to build the control plane which on the T2 medium, and on the T2 micro I'm going to deploy two of the nodes are basically the instances, nothing else. Assume as like your EC2 instances if you are familiar with the AWS thing. If you are using different cloud providers such as GCP or Azure, you have a different instance names. So basically it's like the so nodes are nothing, they are the normal your instance or the servers. So why we are building the Kubernetes cluster and what is the requirement? Before moving on to this, I would like to talk about some of the theoretical parts, because sooner we're going to use some of these particular terminologies while I'm going to build it on the AWS. So I would like to talk about some of the few things and why we are using Kubernetes these days. So the Kubernetes, what is the Kubernetes? According to the Kubernetes documentation, they say it like a Kubernetes is a portable open source platform through which you can actually managing your containerization workloads and the services. So that's the main purpose of you can say containerized orchestration is the whole purpose of Kubernetes. So what is the main issue with the traditional deployment or the virtualized deployment, and why we are using the containerized deployment? So in the traditional deployments, like you have the hardware, you have the operating systems, and you have the applications running. So most of the organizations have their own physical servers where they're running the applications, and one of the application is, for example, you have some sort of a database where the users are using so much, and one of the applications using too much resources of your particular in physical server, then the problem arises the other applications who are on the same particular servers are underperformed. That's the main issue, because either one application is consuming too much resources and other applications are not even able to perform it because they have lack of resources. So that's the main issue arises on when you with the traditional deployment. Then the VM came into the market around like in 2007 or 8 onwards, when you have, or even earlier, I'm not sure, where you have like you on the top of any operating system you can actually install another operating systems. Like even today's most of people, what they do, like they have running the Windows but they want to install the Linux or any Linux based distributions like Ubuntu or Fedora or Red Hat on the top of Windows. So what they do, like they have their operating systems, they have the hypervisors, and on the top of hypervisors they try to install the VMs via the VMware or VirtualBox or another third party. And then you have install your operating system such as Linux or Fedora or the Ubuntu, etc. Now, what's the main difference between the virtualized deployment versus the container deployment, and why should we go for the container deployment? The main reason behind it, with the container thing, it's give us the loosely decoupled architecture. What does it mean is that, like, so for example, this is a container. Before telling about like what is this container is, I would like to talk about the definition. So you can see like according to the definition is saying the container is nothing, it's a standard unit of your software which packages everything, and it's all dependency which is actually required to run your applications. If you have the container which required everything, so for example, if I give you my container, whatever the prerequisite libraries or everything is required to run that particular application, if everything is going to be encapsulated or wrap it up under one hood or one container, don't you think it's a very good thing? Because all I just require you to send this container via some sort of image or some things, and then you can actually run the container on any other computing environments. So that's the main purpose of containers. And it's not only these things, like it's really beautiful if you actually go more deep dive. So with the virtualized deployment, if your applications are running, you can't actually share the resources or load balancing it. What does it mean? Like, for example, if this application having some sort of application is running, and assume this inside this container, now you get to know like the particular resources are using too much on this one. Using a Kubernetes, you can actually route the traffic or distribute your network traffic to the different containers, or to load balancing, or to so that your deployment is becomes stable. So that much Kubernetes is powerful. Now you can ask me like, the Docker does the same things, because Docker is actually the initial ones. So why we are using the containers, I mean the Kubernetes? So the main reason, as like its definition is saying, about managing the containerization workload, some of the things which is actually Docker is not capable of doing. So assume you have like 4 applications running inside the container. You don't need to worry about what is applications, how to build it. Forget about it, all of it. Just assume like you have a 2-3 containers. Inside each container, you have a bunch of applications are running. Now suddenly something happened, some policy or network due to some network issue, or something happened, or the image corrupted, your container goes down. Don't you think there should be some sort of a mechanism? If my container goes down, especially in the production environment, it should be restarted by itself. If you think of like Kubernetes can do that, yes, you are right. Kubernetes is actually capable of restarting your containers if your container goes down. Even if your container fails, not able to restart, you can actually define your own health checks, and based on your health checks, you can actually control, you want to restart, you want to kill the container, or you want to replace the container. So that is much is the Kubernetes capable of. Not only these things, Kubernetes also route your or distribute your network load balancers. Like what does it mean? It's like you have facing too much load on one container, but other containers are completely free. They are not using too much resources at the moment. So you can actually distribute the traffics between the containers through this is actually uh, done by Kubernetes. Another thing is about the storage orchestration. What does it mean is like you can automatically mount your storage systems either via local storage or either via different cloud providers. In terms of the AWS, AWS provides the EFS, which is the elastic file system, through which you can actually automatically mount your storage. Also, I would like to talk about one last of the benefit of using a Kubernetes. You can actually define how much resources or the CPU RAM is required by each container. And at any time, you can actually scale up or scale down based on your requirements. So for example, you have a 4 GB of RAM and you have 4 containers. So you initially decided like each RAM, 1 GB of RAM, I should going to give to one container. So you have 4 containers with the 4 GB of RAM. So you decided one container with 1 GB of RAM. Then you running or deploy your applications, but now you get to know my one container required more than 1 GB. You can actually scale up or scale down with these things. With the VM, with the virtualized deployment, you cannot do that. So you can know like there's so many benefits of doing these things. Okay, so now I would like to talk about I hope you get an overall idea about what is the Kubernetes, why we are using the Kubernetes, and the things which I talk about, all these steps is actually not capable of doing via Docker. That's the main reason the Kubernetes comes into the role, into the picture. And now, so we are going to today, I'm just going to build the control plane using a control plane. I'm going to connect via kubeadm these two nodes, which is nodes are nothing, they are the servers, as I mentioned earlier. What's the benefit of doing this is like so using a control plane, you can actually make the global decisions. So for example, you get to know if your node is getting, or the particular port is getting killed, it should be restarted by itself rather than doing manually in Docker things. So you can actually set up some sort of policies in the control plane. It is act as like a master slave architecture, to be honest. Like if you are familiar with the Jenkins architectures, it's some sort of follows the same kind of architecture. So this is the control plane, or the master, assume as it as a master. So from whatever the decision you are making, it's going to be applied to all the nodes it is actually connected. So I'm going to show it and demonstrate inside the AWS now. So first of all, before moving to this, I would like to talk about, show you about some of the ports which I'm using for my Kubernetes control plane and the worker nodes. So if you notice here, I'm just going to see if my IP is the same one right now. Let me select my my IP. Okay, so you can actually see like this is my IP. So what I have actually did, I provided some of the ports which is actually required, and I provided the descriptions about which port is actually. So the port range from 30,000 to the 32,767, which is the node port services is required, and I only provided my service ID, which is my local service ID. And similarly, I provided the 10,250 port for the kubelet API. Now you can ask me what is a kubelet API? What is a kubeadm? I'm not going to talk too deep about these things, but I just want to give you some overall kind of a picture. What is the kubelet, kubeadm, kubectl, pod, container, namespaces, and the Docker, and what is the Kubernetes? So I already mentioned about the Docker and why we are using the Kubernetes, because Kubernetes can actually restart your containers if balance your container if you're getting too much traffic on one container. You can specify the CPU or the RAM between the containers, automatically fail, replace, or kill the containers. So that much things is actually capable of doing by the Kubernetes. Docker, on the other hand, is nothing. It's just the platform as a service which gives you the OS level virtualization for the containers. That's it. It's nothing else. Docker is apart from this, it's nothing. You can actually manage the containers with the Docker Swarm, but not too much. That's the main reason of using the Kubernetes getting boom and boom after 2014. Now you see there are a bunch of different terminologies I already provided, like the namespace, container, pods, kubelet, kubeadm, and kubectls. So I'm going to talk about one by one. So the first one is the namespace. Just assume at the moment, because these things are actually required me to talk about at least 30 minutes on each things, which I don't want on this video. I'm going to make a few videos in the coming series where I'm going to provide each ones in details. What is a namespace, what is a container, what is a pod in details, and how they're actually working behind the scene. But today I'm just want to talk about what is a namespace. So just assume the namespace is nothing. It's the virtual cluster. That's it for today. You don't need to worry about what is the namespace is actually doing. Container, I already mentioned earlier, container is nothing. It's kind of a small box. Inside the box you wrap up everything, whatever the packages you require, whatever the dependencies you require to run the applications, everything is inside the one box. What is a pod? You don't need to worry about what is a pod. All you just have to assume, the pod is nothing. It's the smallest deployable unit for your Kubernetes. All you have to remember, inside the pod you at least need one container or more containers. Okay, so you cannot have zero container inside the pod. It doesn't work like this. So you have at least either a group of one or more containers, okay, through which you can actually share the storage and the network resources and all these things. What is a kubelet, kubeadm, and kubectls? These are the components, or you can say it's the components of the Kubernetes. So kubelet is nothing else. It's basically the agent through which you have to run on each node. Node is nothing. It's the server or the instance. In our case, we are going to use the EC2. So these are nothing. These are the kubelet is nothing. It's an agent through that runs on each node, and to make sure, it's the main purpose of using a kubelet is just to check on whether your container are running in a pod is fine or not. It's check the status basically. The kubeadm performs all the actions which is actually necessary to get a minimum viable cluster. Using a kubeadm, we are going to join these two nodes, or the instances you can consider, with the control plane. Okay, and now what is the kubectl? The kubectl is a command line tool which is to control your Kubernetes clusters. So I'm going to show you some of the basic commands. Nothing else you have to worry about in details how they are or what is actually they are doing. So I hope you get some kind of a overall familiarity between these terms, and I would like to show you one picture which I actually draw it. So you can actually see, so this is the I try to come up with a very basic picture. I'm going to add more services, which is actually I hide it right now inside the particular node. So you can actually see, I'll start with this one. So there is one container, okay, and inside the container, as I mentioned, can be a bunch of applications can be running, okay. So in our case, like you can see, there are 6 applications, okay, and I have 3 different containers inside. Now the container, you have a bunch of different applications, and inside the pod, as I said, this pod is nothing, it's the smallest deployable unit which is in the Kubernetes, and to each pod have at least a group of 1 or more containers. So I just show you 3 containers, or it can have only a 1 container inside the pod, it's up to you. And now inside the pod, you have also the volume through which you can actually share the volumes between the containers as well, but I'm not going to talk about the volume and the services today. And then this is the namespaces. Now namespace is nothing, it's either you can assume inside the namespace you can have a 1 pod or you can have a multiple pod, it's up to you. So you have the containers, it can be 1 or more, and which is actually inside the pod, and there can be 1 pod or multiple pod inside the namespace, and there can be a multiple namespaces for your particular servers. And node is nothing, it's just the server. So inside the server you can have a multiple namespaces, inside the multiple namespaces you can have a multiple pods, and inside the multiple pods you can have a multiple containerization applications, or at least 1 which is required. So I believe like this is the best way I can come up with a very simple architecture or the diagram you can through which I can explain. So now, as I was talking about the security groups, I didn't open all the ports, only the ports which is actually required by the to build the whole architecture today of the Kubernetes cluster. Why we are building the Kubernetes cluster? So that we can actually, with the control plane, we can handle the global decisions of all the Kubernetes, of all the worker nodes and everything. It works same as it is like if you are familiar with the Jenkins market architecture or the Apache master slaves architecture. So you can see right now, like in the security groups, I provided some sort of a port range. What these port range are doing, I provided their descriptions, like the kube schedulers use the port 10,251 and everything. Don't worry about these things because I already writing down all the documentation side by side, and I'm going to share with you guys as well after this video. So you can find all the descriptions from the descriptions of the YouTube channel, I mean on this particular video. So let's get started and actually run launch the instances. For the control plane, there are some of the prerequisites which is required. You should use at least Ubuntu version 16.04 or Debian 9 Plus or CentOS certain version. So make sure check the version. If you're using 2 older versions, it's not going to work, especially for the Kubernetes. So I'm going to use the Ubuntu 20.04 LTS. And to run the control planes, your minimum requirement is the 2 CPU. And you cannot have like a less than 2 CPU and with the 2 GB of RAM. That's the minimum requirement. So if you are actually try with the T2 micro just for the free tiers, I'm sorry, it's not going to work. So you need required at least 2 CPU with the at least 2 GB of RAM. So I'm going to just provide all this information, and now it's up to you how you want to put your control plane inside the private subnet of your private VPC, or you want to use the default ones. I reckon if you are actually a company's employee or you are building the whole architecture for your company, try to build your own VPC. I already have my VPC, but I'm not going to use it because if I start with the VPC thing, it's going to be 6-7 hours of video, which I don't want. So anyway, so now I'm just selecting the default one, but it's highly recommended the control plane should be present inside the private subnet what does it mean is like you connected the private subnet with it's not connected with any internet, so any threaten only on the nodes, not on the control plane. Because if somebody hits on your control plane, then your whole architecture or your company's architecture will going to be destroyed, devastated basically. So it is always recommended, put your control plane inside the private subnet and then attach with in front of the ALB, the application load balancer, and from the load balancer connect it via internet, or put some sort of a NAT instance or the NAT gateway through which you can actually able to connect to the particular um, your private instances to the internet. That's the best approach all the companies or the infrastructures should follow. But just for the demonstrations, I'm using for the private my default VPC, but it's always recommended the control plane should inside the private subnet of your private VPC. So let's just add the name. So now I'm just going to add the name of this is my K8s master, not master, let's just say control plane. And I already show you guys, like I already created created my security groups, and inside the security groups I set all the port range which is required on my particular IP. Never try to open all the ports or on all the IPs anywhere. If you're doing that, you are the stupid person I ever get to know about it, because it's not recommended, not even by AWS or any cloud providers. If you are doing it, you're exposing your applications to the world, which is not an appropriate thing. So now it's and I also actually have the key. If you don't have the key, make sure you create a new key for launching your particular instance. So we already launched the T2 medium one because it is required 2 CPU with at least 2 GB of RAM. Now I'm going to launch 2 different worker nodes. I'm going to use the same LTS version of 20.04, and now I'm just going to try to skip the process fast because I'm not going to show how we actually did. I'm just putting the number of instances which are required to launch 2, and now I'm just going to add the tag name, which is like K8s workers. And for this one I already have the existing security group which contains only these ports, which is required. No point of providing all the ports. And for this one I already have the key which is downloaded in my system. So now you can see there are all the particular nodes are running. You will see like there are a bunch of other instances I have running. So let me just filter out instance state running. So you will see like there are 6 instances are running. So we have to just focus on the new ones. So you can see like 2 of them is still initializing. So let's just wait for them and filter out by the launch time. So you see like right now, okay, I think it's only launch 1. Let me just refresh it because I selected 2 of the worker nodes. Okay, so I can see now 2 of the worker nodes and all 3 are initializing. Sometimes it's gonna take like for a while, like 1 to 2 minutes, so you have to be just a little patient and wait for them. Once it's going to be initialized, I already separate all my terminals. Like this is going to be my control plane, this is my worker node 1, and this is my worker node 2. The commands part, what is the commands we require to build the whole Kubernetes cluster, I already written down inside my K8 workload directory or the repo inside my GitHub. I'm going to provide the link of this one so you don't have to write it by yourself, because if making a one mistake, you can actually either like hack your whole server. So it always recommended try to copy paste directly the commands rather than writing manually. Yeah, if you want to, in terms of learning purpose, it's always good to know what you are doing. Actually, I'm gonna go through all the commands, what I'm typing and what they are exactly they are doing. Okay, and why we are using them. It's pretty straightforward. So let's just wait and reload it. Probably should now it should be launching. So okay, we can see like it's still in the process, and if you see like the connect button, but I can see like it's give me the particular option. So I just go and try to connect. If it's able to connect, that means it's already started the instance, but I don't think so. The instance is already started yet. Okay, so I can see like it's already connected. And if I just type -UA, I can actually see about my instance. Okay, so we already connected with our control plane in this one. So let's just connect it with this one. So let's just go to connect, copy the name, paste it here. I already provided my the worker node key inside the download directory. That's the reason it's asking. And I also changed the permission to the read permission only. If you receive some sort of a message that you have to change the permission, so using a chmod, change the permission of your key to the read only. Otherwise, it's going to give you a warning or it's not able to connect you. So now almost we are able to connect with all 3 instances. So now you can see like we already connected with all 3 instances. I'll say yes. Let me clear the screen. Now to run to build the Kubernetes cluster or to run the Kubernetes, we required some sort of components like kubectl, kubelet, or kubeadm. Now to do so, we required some sort of a container runtime. So Kubernetes give us the 3 different options at the moment, or even more, I'm not sure, but I know about the 3 options. It gives us the options: you should install Docker, and after installing Docker, disable your swaps, and then you try to install your kubeadm, kubelet, or kubectl. Or since Kubernetes is actually don't require the whole Docker, so you can actually use the container runtime. So for this purpose, I'm going to use the containerd because it's not requirement of using a Docker, the full Docker, because we are not going to use the some of the features, extra features of Docker, because these features are actually be able handled by Kubernetes. So there is no point of doing some manual more work while installing the Kubernetes. Okay, so for the first step is required is to install the container runtime, and there are a bunch of different container runtimes. So there are like a containerd, there are kata container. So this is container runtime, one of the container runtime. This is a kata containerd, and there is a CRI-O, CRI-O, which is another container runtime. CRI is nothing, it's a container runtime interface through which you are actually, which is required to run the install all the components and to run the Kubernetes. So first of all, what this command is doing, I'm going to show you as well while running. So basically what we are doing is nothing, we are just creating one containerd.config files, and inside the config file we are providing 2 of the modules which is required for the containerd, which is the container runtime interface, CRI. So we actually just providing, which is the overlay and the BR net filter, and I'm going to provide copy paste the whole commands on all 3 of all the nodes. So this is our control plane, and these are the nodes. Nodes are nothing, just the servers. So now using the sudo prob, what we are going to do, we are actually loading the modules. So first we actually, if you go inside the cd modules, if yes, I'll just going to run like a sudo vim. I don't think so I require vim, so I'll just going to show you. So this is the one which we actually defined just right now, and now we are using, actually after defining the modules, we are actually loading using the sudo, so that we don't have to restart the PC or the servers, I mean. So now after creating the containerd.config file, where we provided 2 of the modules which is required by the containerd, one is for the storage and another one is for the networking. So now we are actually loading them. So now you can see all 3 are load in all 3 servers, and this is basically required by the Kubernetes, or you can select for the container runtimes. It's basically just for your networking stuff. So basically what we are providing inside this one, inside the config file, so we are creating this config file where we're providing about the IP tables, IP version 4 and IP version 6 of the tables. And so now you can see like it's actually created on all 3. Nothing else, just very basic simple stuff, to be honest. So now rather making a reboot your systems so that every packages you actually load or install like define the config file. So we want to refresh your system. So using the sudo ctl hyphen system, you can actually reload all the packages rather than the another way is like a reboot or restart your servers to load the packages. So we are just loading. If you are from the Linux background, so these particular commands are very straightforward. You don't require too much. So now we already see like we actually create one config containerd config file where we provided two of the modules, overlay and the pr_nat filter. You can add more modules depending upon your requirement, but these are the basic and prerequisite. If you don't have these two, it's not going to work. So now I already installed, provided these modules and then I load them. And similarly, we define for the networking stuff of Kubernetes, the same one inside the Kubernetes-CRI.config. Now we just refresh it, the parameters, and now we're going to actually install the containerd. So what we are doing, like I'll running all the commands same times and all three. I'm just going to show you. So basically what commands we are running, first one is like nothing because I'm using Ubuntu, so these are all commands based for Ubuntu. But don't worry, even if you are a user using a Red Hat or Fedora or CentOS, I'm going to provide each documentation for each ones. So you don't have to worry about like, and also I'll specify for which version which commands you required. So now you can see, so we are doing here nothing. We are just updating the packages and we are saying install with a hyphen. Y is saying like install, it's saying yes, install all the packages, don't ask my permissions right now, and install the containerd. Then we create one directory inside the etc, and then we are just defining creating a config file.tom, and then we are restarting the systemctl. So once everything is going to install, you can actually run the sudo systemctl status containerd. If you see it saying active running, that means it's actually your containerd is already installed and running fine. Okay, so similarly you can actually check it on everywhere, on every different node. Also, I would like to show you some other thing inside, because if you remember from this command, we actually create the config.toml. So if I'm just showing in the particular this one, so let's just go to the containerd. Okay, sorry, it's cd. Okay, I'll have to change my directory. Okay, I'm on the root user, so let's just go to the containerd. Okay, so currently the directory is not created. Okay, no worries, we're going to figure it out later on. I'll just want to show you once it's actually what's inside this directory and how it's actually working and why we required it. Anyway, so Kubernetes documentation didn't specify these steps, but they mention in their documentation that you require to disable the swap off. Now assume you don't know about this step, and I'm going to skip it, and I'm going to show you what the error you will going to face when you try to install the particular kubeadm, kubectl, and kubelet on your servers. So I'm going to skip this step and let's see what will going to happen. So for the first step, what we are doing, we are installing some of the prerequisite the libraries or the packages. One is the apt-transport -https, and another one is the curl. I reckon the curl is already installed because I'm using Ubuntu. So let's just try and run this one on each of the servers. So now you can see like the packages are installed. So once the packages are actually installed, we are actually going to add the GPG key on all three of them. It's pretty straightforward, to be honest, guys. Like if you are from the Linux kind of a background coming from, then these are very straightforward. So now I already added the GPT key. Now I'm going to create one Kubernetes.list where I'm actually providing like the information. So basically we are inside our resources.list.directories, we are adding Kubernetes.list. So now you can see it's actually added. That's actually the requirement of before running your kubeadm and all kubectl and kubelet. Okay, remember we didn't perform this step because they didn't provide us in the documentation, but they said you have to disable it, and I'm going to show you what happened when you try to install before without doing this step. So I'm just going to run these two steps and make sure try to use, I'm just going to show you here as well. Always try to install the Kubernetes latest version, not the beta ones, but the stable version of Kubernetes, which is currently 1.20.2 or 1.20.1. The reason behind it, if you are actually preparing for the Kubernetes administrator exam, this is actually it's going to help you. The differences are not too much, to be honest, but actually within 3 to 6 months, the CNCF, which is the Cloud Native Foundations, they whenever they conduct the exams, they try to use the new Kubernetes version. When I give my exam, I use it was 1.19, which is like in January, but now it's 1.20. So probably when if you are going for exam by March or April, probably you will see they were asking you to they were going to give you all the questions, and the versions they are using on the clusters is the 1.20. So it is my highly recommended, don't go for very old versions. If you're learning purposes, then it's all good to go, but if you are not, then there is no point. Okay, so you can see I just updated the packages, nothing else. We already created one of the Kubernetes.list. Now I didn't disable my particular swaps. So now see what happened. Is it going to install? Is it not going to install? We're going to see. So it's look like it's actually installed, right? Now let's do the same thing on my both of the others nodes. And using the apt mark hold, I'm just saying hold the particular version which I actually install is 1.20.1 of the all the three kubeadm and kubectls. So I don't want like to upgrade to the new one. So I'm just setting up to hold on all three servers. Okay, now if I'm actually going to connect with this one, let's see what will happen. It sometimes it's like takes a couple of minutes. Last time when I tried to install, it consumes like less than 1 minute. So it's completely depend how much it's actually taking time. So let's just wait, and everything once it's going to be installed, then we are actually provide this directory. We're going to create a directory and we copy all the files inside the configs, and then we are actually going to change the permissions. So, and these all three steps is actually provided when you actually run the kubeadm. And what this command is doing, nothing is, we are just saying the kubeadm init for the pod network CIDR range, which is this range we actually provided. That's the basic range with the 16 subnet. So we have like 2^16 minus 5 in terms of AWS, because 5 of the IPs are actually reserved by the AWS for their own uses. So now you can see like we get everything to, and they mention about like to start using your cluster, you need to run as a regular user. So let's just run the command, copy all of them, and I'm going to create. Before creating, you can see like there is nothing inside right now. I'm going to show you as well. You can see there are a bunch of files, but there is no file directory which is the kubeconfig cube inside the .cube directory is not created. So now we are going to create and change the permissions, and now I'm going to performs the same steps on the another ones. So we already actually installed them, and this steps forget to mention only the steps from this one, starting from init the pod and connected via this, is actually required on the particular your on control plane. Now one thing, as I mentioned, the using of a CRI is because other components or add-ons is actually provided by Kubernetes. So one of them we are going to use for networking is the Calco network. Using the Calco network, we are actually able to connect. So you don't need to worry about like, oh, what is the kubectl apply -l command is doing. But I want to show you, because kubectl is the command line tool, and if you just type kubectl -pod -a stands for show me all the ports you are actually having in all the namespaces. So you can say we only have one namespaces inside this server, and you can see the Calco one which I actually install, it's the status is like pending and it's initiating. So let me just run the same command. You can see now the status is changing from pending to running, but the nodes are not ready, like the ports are not ready yet. So let's just run it again until unless the ports are running. So now you can see like this particular, the core DNS is now changed to 101. So now we can see like everything is set up accurately. So let's just going to try and copy. So either there is a way, so you already have the kube ADM, so you can see like you can join any number of worker nodes by running the following command and on each as a root user. So what am I going to do? I'm just going to provide sudo in term if you're using the particular let me handle this thing. Okay, so it's not copying the same commands. Anyway, so let me do one thing. Okay, let me change to sudo su, and then I'll just going to run the command. So let's just see whether it's able to connect it or not. So now you can see like we install the kubeadm init on the pod network on the CIDR range, this one, and after installing and configuring accurately, it asks us to start using your cluster. You have to need the create this directory, copy all the files from admin.config to here, and then change set your permissions. And alternatively, you can actually expose the same things via this, or otherwise you can actually should now deploy a pod networks to the cluster. And you can see like they are asking us to join the worker nodes. You require to run the kubeadm command. Now if you notice, it's unable to join. Now there can be two different reasons for not able to join. The one is maybe the swap is on because we didn't disable the swap. That's the main reason I show you guys, like swap you have to off in the control plane as well as in another planes, otherwise it's not going to work as expected. So let's just swap off. And so what is this command is actually doing is nothing. It's the sudo swap off -a is just for right now, but using the second command I'm saying like to disable the swap on, even I'm going to restart my particular server, still the swap should be disabled. I don't want to make the swap enable right now. So let me just terminate this one and run the swap off -a on each one. And similarly here as well, sudo swap off. Disabling the swap is actually a requirement of installing the Kubernetes. So you should be careful when you are actually doing this one. So currently also using the kubectl get nodes. Nodes are like because this is our control plane. Once we are actually connected all the nodes, you will going to see here. So you can see like there is only one kubectl node, which is the control plane master one. So there is no another nodes, like these nodes are not actually connected with here yet. So now I'm going to copy the join link again, and I'm going to try. So let's see whether it's able to work or not. Even if right now it's not working, so there is the chances that your security group is not giving the permissions to join. So if it's that the case, what we're going to do, we have to open some more ports or check the permissions. So let's just wait for like a couple of seconds, and if it's not working, then I'm going to change my particular port settings on the security groups, and let's see how it works. So it's look like it's not working to me. So what I'm going to do, let's go to the EC2 instance. I think I already have the control. This is my control planes, security groups, and this is my worker node. What I'm going to do, let me add the custom TCP, not custom, all TCP anywhere, and let's see if it's able to connect it here on this particular worker node, then we are all good to go. And similarly, let me just try with this one on this particular custom ID with all TCP anywhere. So just wait for, so you can see it was actually the security port issue from the master node, not from the server node. So now you can actually see it is able to connect it. So let's just run kubectl nodes. Now you will probably see the worker node 1, which is connected but not in a ready status yet. So you can see their IPs. So this is the 50.92.1, and similarly I'm gonna continue and run the command from here. Sorry, my bad. The command is here, kubectl and everything, and now run the command. You require to have a sudo, which I forget. So if everything is set up correctly, you should be able to connect it with your control plane. So now you can see we are actually able to connect it. Note, if you are actually run here like kubectl get nodes, I assume it's going to say you some sort of like you are not the master or something. So it's actually refusing the connections because the kubectl get nodes is actually worked on the control plane or the master node. Now if I'm going to run again, we can see all three status are running and they are already connected, and we are using the version 1.20.1. so that's it. Like so what we have done yet today, we actually install like all the packages. I'm just gonna open the directory again. Dapper. I'm going to provide all the links and the documentations, whatever I mentioned here. And I'm going to add, guys, a lot of Kubernetes series now in depth in detail. Even if you want like go in deep dive on any particular topic about Kubernetes, or you want me to build from scratch in terms of like building a VPC inside the VPC, put your control plane inside the VPC in the private subnet or something like that, I can go deep, as much as deep you want, but it's up to you guys, like how much familiarity you guys have in terms of the knowledge about Kubernetes and AWS. So what steps we follow, we actually install the we first create the containerd.config. I use the containerd as a container runtime environment or the container runtime interface. You can actually use CRI-O or the Docker. There is no requirement of Kubernetes to run of the Dockers. That's the best benefit. So even if in future Docker is not a part of Kubernetes and Docker say like we are not going to work with you with the Kubernetes, we still don't have dependency now. So that's the main purpose. With the Docker you can easily do it, but I'll just show you with the container runtime interface. So we first actually created the containerd.config files where we load two of the modules or the packages. One is the overlay and the br_nat filter. Then I actually load them, and then we are actually do the kubernetes.-cri.config files. And then inside we provided just the network bridging IP tables and IP version 4 and IP version 6. And then we refresh the parameters, or you can say without rebooting, like a system ctls basically get to know about those parameters and the configurations we set up. And once everything you actually provided the config file with the modules and load the modules, now we install the containerd, and then we created the directory inside the containerd. Yes, I remember one thing which I have to show you, which was earlier I'm not able to show you. So let's just go to inside the containerd. Let me see. So there is a one folder created for the containerd. Probably you will see somewhere. Okay, I just want to see, like, is it created the containerd? Okay, so I'm not sure like where is this folder is actually. Oh, okay, container. Let me see, is it a file? Okay, that's really strange. I don't know, like where is this because I'm not able to see right now the containerd folder at the moment. Anyway, but if you go to the kubelet one, which is inside your var lib kubelet, I hope I have the permission. Okay, permission denied. Okay, let's just change to sudo so that I don't have to issue. Okay, so let's just go inside the var lib, and you will see like there are a bunch of different folders. Let's just focus on the kubelet, and now you will see like there are config.yaml file, device, all the packages. Now I would like to show you inside the config.yaml file. So this is your actual kubelet file, config file, and here if you want to change, because with the CRI of the containerd, it's by default use the C group as a C group FS. If you want to use the system MD as your C group name, you have to specify with the C group driver colon then your driver name. So like you're just going to provide here. It's the step like if you guys are not using the C group FS, which is the default in the containerd, but if you want to provide like you have to provide C group driver, and then you provide the system D, the name of your particular C group name if you want. So this is one thing which I like to tell you guys. So let's just come back from here, exit the particular. So let's see. Okay, yeah, so basically now I think you get an overall idea of the containerd. So once we install it, we actually configured the files inside the container, inside the etc directory. I want to see this file, like where is this file, but I'm not able to find it. I'm not sure why. So let's just see, there's a containerd file. Or maybe I'm heading as a sudo su. Let me run it now. There must be a containerd file has been created for us, and I would like to look at it, the file, so that I can actually show you what's inside that particular file is actually contained. So there is no file inside the containerd. So there is no directory, there is no. That's really strange, to be honest. I reckon I already created this one. Let me just run it again and see like is it created or not, because I'm not sure whether this is actually created or not. It is actually required. Okay, okay, so now I can actually see the file. So now probably if you go inside the containerd, so now there is a particular file which is the config.toml file which we just created. I'm not sure why it doesn't create it earlier. The reason why I'm going to show this file, because you have to provide for the systemd as a your group name. So if you see, go back here, so you see like this information where we are providing plugin with the runtime, the containerd runtimes, and this is the containerd runtimes run. if you want to provide the use system DMD as your C group name, you have to make the particular create one variable which is called the system D configuration equal to true. I'm going to provide the documentation for that one, like if you want to use the different C group names if you required. So that's the main one I want to show you guys. So let's just get exit from root user because I don't require it anymore. That's the main one which I was wondering why it doesn't create it earlier. So yeah, so like if you just run the kubectl nodes, not nodes, my bad, nodes, you will actually see all the nodes which is actually already connected with your control plane. So we can see like there are 3 control planes, they are steady and running, but we didn't attach any roles to them, but we already just connected with them. And if you just running like a kubectl get pods, there is no resources found in the default namespace. But if I'm just going to type -a, which is the additional parameter, I can see there are in the kube system namespace, there are different particular pods are running. So you can see their status, whether they are failing or they have something. And I also like to show you about kubectl get deployments. Let's just see any working here. So oh sorry, my bad, it's a deployment. So you can see like there is no resources found in the default namespace, but you can see there are 2 of the namespaces and there are 2 of the deployments files are inside the kube system, kube under hyphen system. What are these deployments and the configurations? I'm going to start making step by step for you guys. So don't worry about these commands and how you should be familiarize yourselves. What is the pod? What is the namespace? How you can actually create your own configs files and deploy and build your applications. So this particular the demonstration of the video is just to illustrate how you can actually build a highly available Kubernetes cluster. So we actually build the control plane, we connected the worker nodes, and in our case we use 2 of the other EC2 instances. Make sure all of them are under the same regions. It doesn't matter about the availability zone, but they should be under the same region. If you're using different region, it's not going to work. So make sure you have under the same regions. And the minimum requirement for the control plane having at least 2 CPUs with the 2 GB of RAM, and using at least 16.04 Ubuntu version for the control plane. In terms of Ubuntu, for I think Debian is like a 9+ versions there. You can see I'm going to provide the link and the descriptions like what's the minimum versions you should be have for building this Kubernetes cluster. And yeah, so that's it from my side, guys. Like let me know how you like this video, although I'm not sure this video is too long or not, but I try to go as deep as possible for you guys, like to get understanding about like why we are using the containers and how containers actually resolve or like resolve our issues earlier from virtualized deployment or from the particular deployments issues. So yeah, so like you can actually see I can see like I hope you like this video. If you like it, please subscribe to my channel because I'm making more and more videos on these things. And let me know what topics you want to cover in Kubernetes or in cloud side. I cannot guarantee that I'm going to make videos in every week because I'm always pretty much occupied with other stuffs. And this is just for like for you guys, just to get understanding, get to know about like what is a beautiful thing is Kubernetes, and what is I'm really amazed with the Kubernetes. I'm really evolved with Kubernetes stuff. So a big shout out to them, the people who actually behind the scenes who actually created this service for us. That's it from my side, guys. Have a nice day and enjoy your weekend. Bye bye.